Jay's Custom Creations is sponsored by Bits and Bits. Use the code JBates to save 10% off your next router bit or CNC bit purchase at bitsbits.com. This video is probably going to be pretty long, so I'll go ahead and put the timestamps on the screen. That way, for future reference, you can jump to a section that you want to see. If you're watching this on YouTube, I'll put those timestamps in the description to act as chapters. You can click through the chapters. And of course, if you're watching this anywhere else, I'll have those timestamps listed as well. This is what I'm calling the ultimate OneFinity CNC cart. So this particular machine is a OneFinity X50 Journeyman CNC machine. It is not mine. This belongs to a friend of mine. As a matter of fact, he got it over a year ago. And when he got it, his name's Bill. I said, Bill, you gotta let me do a table cart, something for this thing, because I absolutely love this type of functional engineering, designing stuff that works. I prefer to design this type of stuff than design actual furniture. It's just the way my brain works, and I'm just really interested in this type of stuff. But it doesn't make sense for me to go out and buy a bunch of CNC machines that I don't have to make one specific to each CNC machine or whatever. So he got this, and I saw it as an opportunity to do something cool. So thanks, Bill, for letting me have fun making this. So there's a lot of stuff to cover, but the very first thing that I want to cover is clear intentions, right? I want to make my intentions crystal clear when it comes to this particular design, this particular build. When I made my workbench video several years ago, I started that video by saying, it doesn't matter if you want to use power tools or hand tools. It's just basic construction principles. It's basic design, so it doesn't matter which one you can use. And then I proceeded to use power tools. And a lot of people yelled at me because I'm saying you can use hand tools to make something, but I'm not demonstrating that. So I want to make my intentions crystal clear with this by stating, I didn't use this CNC machine to make the majority of the larger components. I used my CNC machine, which has the capacity of a full sheet. But that being said, you absolutely can cut everything on this machine with the use of tiling in VCarve. And I'm sure Fusion 360 has something similar. The tiling feature where you can utilize the pass-through of the machine to cut a little section, or in this case, 1/3 of the sheet, tile it, 1/3 of the sheet, and then tile it for the last third of the sheet. So you most definitely can cut every bit of this on this machine, but just know that I did not, and it was never my intentions to do so. My intentions were to make a really, really cool feature-packed cart, and then present it in such a way that, present it for my audience, kind of a thing. So that's my clear intentions. Don't yell at me for using another CNC machine to make parts for this. You most definitely can cut everything else out on this. One of the main reasons why I did it on a full sheet is, number one, time. You can tile on here. It's just going to be a little bit more time consuming. And number two, the biggest reason why I cut the majority of the pieces on my machine is dust collection. Bill has the dust collection system for this, but he didn't drop it off with the machine. And I also wanted to actually see the bit doing some work while we're actually working here. So dust collection is really the major reason why I cut the majority of the stuff on my machine. All right, so files available. I have a downloadable package that it has a tremendous amount of information in it. In the digital files that are available for this machine, I have the SketchUp file, which includes 2 designs. Design 1, which I included in the SketchUp file because there's no sense in deleting it, and I'll tell you why I didn't go with Design 1. The SketchUp file also includes Design 2, which is this one that you'll see right here, as well as a layout diagram for all the pieces. The other digital file that's available is all of the vectors for all this stuff for CNC use. Or you can simply use the VCarve file that I created for cutting everything. You could use that file as well. Also included is a machine file. Now, a machine file is, I'm sure other people have called it a machine file, but I started calling it a machine file because it's basically a template specific to this particular machine. well, not this particular machine, but specific to what the machine cuts out for the setup. Maybe that was kind of confusing. Basically, a machine file is a giant template specific to this setup. So it'll have everything included in the machine file, which includes the spoilboard, the corner fence, the adjustable wide stop blocks, knobs, and the hold down clamps, all the mortise and tenon joinery specifics. That's right, mortise and tenon, and box joint joinery. So you can't hardly see it from this angle, but right over here is a vertical table. Fully featured, really nice setup. All of that is in the machine file. Another digital file that was included is the PDF plans. Now on the PDF plans, you will have a shopping list, dimensioned drawings for every single part, and a 3D assembly guide. So that's everything that's included in the digital files available for this. So let me put this piece of paper down and actually give you a demonstration of what everything is on this particular machine cart, on this cart. Whew. This design that I came up with is kind of like I'm wanting to call it like an inside-out torsion box-ish. Basically, there's two main boxes for the design and three major webs, which are these face frames. Okay, so on this side, we decided to go with trays or drawers. I'm calling them trays because they slide through on both directions, and there's no drawer slides. It's just a tray that slides back and forth. So on the top tray is your bits and whatnot, and I'll show you that in detail. And then, of course, there's two larger storage trays. Now, they push all the way through to the other side, so you can access them from either side. On this side, we just went with an empty space for kind of like a flex space. So the way I've been using this as I've been completing everything is I've actually been using it for component storage, right? So if you have a bunch of smaller pieces, like let's just say this is an offcut for a project. Well, this is not scrap by any means. It's just another piece of material that you can use for another project. So you can store all your offcuts or small pieces in here. And that's basically how I was working with the open space. However, it's sized so that we should be able to fit a shop vac in the back side, a smaller shop vac, not like a huge, 16-gallon or 20-gallon monster shop vac. It'll smaller shop vac in the back and then an air compressor in the front. That's how Bill's going to use it anyway. So he'll probably have a hook somewhere right here for air compressor nozzles that we can, have compressed air at the ready whenever you're working with this. So that's why we left that side open. However, with just a little bit of work, you could also add some drawer runners and put drawers over there as well if you wanted to. Actually, no, you can't, because there's T-nuts on the inside here and they will interfere. So scratch that. I just thought of that. So that's the front of it. Now, let me spin you around and show you the control side over there. Now, as you can see, I've got one swivel caster and two fixed casters, which I'll show you why I did that. On this side, you can see that the control box is mounted right to the side, and you can see how there's an interior cavity that goes all the way through, and that's to access the T-nuts that are in the tabletop, not the spoil board. Get into that later as well. There's a couple holes for routing the wires and whatnot. There is holes on the inside over there to route the controller into the top tray, which I'll talk about. It's really cool. And these two casters are fixed casters. I probably already mentioned that, but that's this side. Nothing groundbreaking on this side. Let me spin you around once again. And these casters, by the way, this is the second time I've used these particular casters. They're really, really nice. As you can see, it moves really easy. So I went with a tripod setup for the casters. So there's only three casters, essentially a tripod. What's the benefit of a tripod? A benefit of a tripod is stability. It'll never rock. If you put four casters on here, well, anything in my shop that has four casters or four contact points with the ground, it is highly unlikely that it'll sit without rocking, because no matter what floor you're on, it's never absolutely perfect, for the most part anyway. So by eliminating one of the swivels and just having one swivel tube fixed, it's essentially a tripod, it'll never rock. Now, when it's like this, I've got feet right here too, and I'll show you in just a second. When it's like this, and there's a bunch of stuff in the drawers, it's going to be nearly impossible for this thing to just tilt on its own. I'm 180 pounds, and if I put all my weight on this corner, it's still not tilting over. So I don't think that the extra feet are necessary. However, I put these on here kind of like an insurance policy, so that once you find the location that you want, you put the feet down, and it's really not going to tip on you at all. Now, these casters I really like for various reasons. They operate smoothly, and I've had some on one of my other carts here in the shop for quite a while, and they're holding up great. So I decided to use them on this. But they're what I call down-down locking casters. So you press down to lock it, and you don't have to get your shoe underneath it and pull up and tear up the top of your shoe. You also have another lever for unlocking it that you kick down. So down to lock, down to unlock. I really like those. I really like that setup. Also, these feet have a little bit of an angle cut on them. And you may see in the video when I install them, I'm not sure how I'm going to edit this, but you may see in the video that I had them so that the taper to cut is on the inside. Well, I switched it so that the taper is on the outside, essentially acting like a toe kick, giving yourself a little bit more space right here so you're not going to kick it as easily anyway. So that's why I twisted those. And while I'm on the topic of different in the video versus in the what you see in the video versus on the files, this is a prototype, right? So as I'm making this, I'm building off of my plans, but as I'm making it, I'm seeing stuff that could be better tweaked slightly. So there's some stuff that you may see on this particular prototype that is different than the plans, and that's on purpose. Always, always, always use the plans, use the files for specifics and for confirming dimensions and whatnot. Always use that, because that's going to be the final iteration of the design. Only use the video, what you're seeing now, as reference, okay? So if you see something in the video and it's not on the plans, don't trust the video, trust the plans. On this side, or the right side of the cart, is the vertical table. And it's pretty darn awesome. It's not a full width table, because I have a full width table on my CNC machine, 49 inches of vertical table. And I did that because I thought that there would be times where, picture like a waterfall table. You have like a computer desk where you want to have that waterfall effect. So you have a full width top and a full width side that you want the grain to continuously go through. Well, that same concept maybe could be done with integral dowels on the whole side of the cabinet or side of the desk or whatever. You cut integral dowels, and then you cut the integral holes on the top, and you glue it together like that. It's an interesting kind of a look. Well, I made the full width vertical table on that one to accommodate basically that scenario where you're doing a full width of a panel of some kind. And I've never actually used the full width. So on a machine like this, we talked over what he probably would use it for. And it's basically mortise and tenon joints, and then box joints. Of course, you could do dovetails as well, but those are probably the most common, is mortise and tenon and box joints. And for that, we went with 11 and a half inches of capacity left and right for the width of the material inside the vertical table, and about, actually I can take a measurement real quick, 2.5 inches of thickness of the pieces that you can put down inside it. Well, that's actually for the cutting capacity of the machine. You could put thicker pieces in it, but the cutting capacity of the vertical table is 2.5 or 2 5/8 of an inch by 11.5 inches. And we'll get into the specifics and show you how this actually works. It's really cool. I've got some test pieces that were cut on this machine. I love joinery on a CNC machine. It's just so much fun. Before I spin it around, I want to show you the back. It's a mirror image of the front. Very basic. One note though, when I talk about putting the controller inside the top tray, and you'll understand what I'm talking about in a little bit, just know that the wire is fed into here through the top, so that you can't pull this all the way to the back. So if you put the controller inside this top tray, the tray is only accessed through the front side because the wire is in the way. Everything else can be slid out however long you need it to. And of course, there's some extra real estate up here. If you want to drill holes and use this as like bolt storage or whatever, hardware storage, this is just an empty space that's required because the back side of the spindle can only go, or the back side of the gantry can only go so far. So extra real estate up here, use it however you want. Next up is the corner stop or the fence, whichever you want to call it. That's what these pieces are. This is a side fence and a back fence. Where they join up right here is a reference corner. So in the machine file, if I want to cut something on here, I open up the machine file and I draw this rectangle, my material size, locating or starting off of this exact corner. And that way I know exactly where my material is and make all my cuts without ever having to change the origin to reference off of the corners. So this touch-off plate, right? A lot of these machines have the touch-off plates where on one side you can touch off into the middle. Well, then it's got a corner locator that you can click onto the corner of the piece, and then you can measure off the sides, and based upon what's set into the controlling software, it'll set your origin to exactly at that particular corner. That's super handy, that's super good, but it's a waste of time once you have this particular setup. With this particular setup and the machine file, you load all your pieces and do all your designs on the machine file, which means you never have to change origins. All you have to do is home the machine in the same spot every time. Once it's homed, all of this locating data is baked into the template, the machine file. So why put it in the back left side? Oh, by the way, this little touch-off plate, I just store it on top of the control box over here. I thought about putting it in the drawer. I actually had it in the drawer, but it was just kind of too many wires kind of in the way. It sits just fine right there and doesn't move. So why have this fence in the back left corner rather than the front left corner, which is where typically everybody puts it? The reason being is making the easiest stuff to do furthest away from you and the hardest stuff closer to you. Now, none of this is hard, but think about this. How difficult is it to put your piece down? It's kind of silly to say. It's super easy. You just put it in the corner. Literally, it's all you. Push it forward and sit in the corner. Then put your clamps down, which is, again, easy, but more difficult than putting this down. So put your clamps in the front so you don't have to stretch all the way to the back side to do the difficult stuff. It's easy to stretch to the back side to drop this in place. It's easy to have all of your clamps right in front of you. So it's the same thing. I just switched them around so that you're referencing on the back side. Basically, less stretching to install some pieces. What else is on my list? So stop blocks instead of hold downs. If you are using a CNC machine like this, a desktop CNC machine, the majority of the stuff that you're doing is done with a end mill and a V-bit. That's the majority of everything. And the majority of the end mill cuts are down cuts. And of course, V-bits don't have an upward pull. So the whole time, there is no upward pull. If you're using an upcut bit, it's going to want to lift your material. And at that point, you would want to do some top-down work holding. But for the majority of things, everything cut with a down-cut end mill and with a V-bit, having a setup like this is just fine because you don't have the piece wanting to lift. That way, you just have friction stops in the lateral directions, left and right, up and down, forward and back rather, X and Y, my goodness, X and Y directions, just have lateral stops and don't worry about top-down holding. Now, if you do have to worry about top-down holding in a situation like this, you can pop some of these bolts off and use these holes for some clamps over here, however, as needed. These stops, these fence pieces, are just held down with these bolts. They're not actually located with the bolts. Inside here is 1/4-inch steel pins, which make this very repeatable and easily fixed and replaced. And I'll get into all that in just a second. So stop blocks instead of hold down clamps are the primary use. A quick note on knobs and the hardware. First off, all of the T-nuts in the table and in these knobs are 5/16 by 18 thread T-nuts, so all of the bolts are 5/16 by 18 bolts and threaded rod. So I did not make any of these knobs in this video. I've made so many of these knobs over the years. I did not want to go through the hassle of just making some more of them for this video. However, the vectors to make these and the toolpaths, they are included in the machine file. It's nothing specific to this particular machine. It's just a generic knob that I've been making for years. Also is some hold down knobs, hold down clamps as I walk over to the other side of my shop real quick. This is a hold down clamp utilized with these knobs, right? And this clamp is just a piece of scrap wood that's got a slot cut in the middle of it, and then 2 rabbets, one on either end, so that way you can hook over your material. Not only do you hook over the top of it, but you get a physical stop with this corner right here. So this right here, I didn't cut any in this video, but the vectors are included in the machine file. I've got so many of these, it doesn't make sense to make more. Now, with knobs, you can make your own. You can buy some that are already manufactured. You can make your own clamps, or you can buy some that are already manufactured. It doesn't matter which one you choose. But what I will say is I have used these so much over the past few years on my CNC machine. And if you're just, doing a couple of these, no big deal. It's no problem whatsoever. But picture this scenario. You have 30 parts to cut out, and each setup for each part has 4 knobs to lock everything down into place. That means 4 times you have to tighten it down, and when it's done, 4 times you have to loosen it up. Times 30 pieces for that day, that's a lot of twisting and finger fatigue. At the end of the day, your fingers will feel it, and I'm speaking from experience there. That's painful on your fingers. So something that I started doing while making this video is not using knobs at all, using a 12-volt drill with a socket, and just using the bolt with the clutch setting on the drill. And I will say, after doing this for the past week or so, making this cart and prototyping this and debugging this, using this drill and these bolts is my favorite thing to. I prefer that more so than the knobs, because with a drill, obviously you're just pressing a trigger. There's not much finger fatigue over a whole day of doing that. So the bolts is probably what I'm going to transition to whenever possible. Now my ecosystem, my CNC ecosystem is set up for this particular scenario right here. So it's going to be difficult for me to switch over to this. And also I have T-Track on my table. We didn't want to do T-Track on this one because of the cost. It's way cheaper to do the T-nuts. And it's not that big of a deal if you put the T-nuts in the cart and not on the Spoilboard. I'll get into that later. So there's a quick word on knobs and the fact that I prefer bolts rather than tightening with an actual hand knob. And if you do want to make a bunch of knobs, to be honest with you, it's a lot easier to not make these knobs. I've gotten to the point where I don't care if I'm using a knob or not. It doesn't look any. The only difference is it looks. It functions the exact same way as a square. So just cut a square piece, drill a hole in the middle, pop a carriage bolt in here. That's what this is a 5/16/18 carriage bolt. The threads go all the way through it, so I drilled a 1/4-inch hole, and then I just manually threaded this through that hole. Once it stuck out about 1 inch on this side, I put 2 jam nuts on here and then used a wrench to drive it all the way through this direction, burying the head inside here, because on a carriage bolt, right below the head is a square shank, and that square shank needs to go into this. There's no adhesive whatsoever, no glue, it just locks into place. And this is probably what I'm going to use for knobs going forward. If I ever need to make a bunch more knobs, I'm just making rectangles. They do the exact same thing, and while it's not as pretty to see as something like this, it's way easier to do. And as far as my material being held down, I don't care about pretty. I care about easy. I want to get to work, you know what I'm saying? So there's a quick note on some knobs and work holding. This is the vice jaw, I guess you could say, for the vertical table. And I'm going to take it off and show you the inside in just a second. But you'll notice over here in the top left, the wires for the motors here, there's a clip on the front side of this axis. There's the wires that go through here, so we have to have access for this. Now, this was an afterthought. Same with the holes for the wires. That was an afterthought too. So This is just a basic notch. It'll all be refined in the final vectors. Also, this is the more refined version of the vice jaw. When I installed this, which you'll probably see later on in the video, I used 3 independent vice jaws. There was a bigger one up top, and I only had ash on hand that would fit that piece. And then these 2 bottom pieces were made out of walnut. Now, it was hardwood. I put cork on the other side. It would function just fine, but I couldn't get over the fact that it was 2 different species of wood that just looked goofy on here. So I said, all right, there's got to be a better design. Paused on that, and then came up with this piece of MDF to match the rest of it. Now, there's 2 pieces of MDF, and on the inside of this is some of that, I think it's Andy Klein cork rubber. It's the best grippy stuff that I've found. A lot of people tell you this exact same thing for the inside of vice jaws. It works really, really well. So there's that. Let me take these knobs off and show you how this is assembled. So when I mounted these bolts, I did all this by hand, just lining stuff up, putting bolts in there. The holes for the T-nuts that are inside the cabinet will be included in the vectors, so you don't have to drill any of this by hand. Now you have slots instead of holes for these bolts, that way the vise can rack a little bit as needed. And I allow that because you always reference off of the left side in this setup here. And anytime you have a 2-screw style vise, you don't always have to operate both screws. What you can do is put your material to the left side and then over tighten this side just slightly. Let's just say you're using 3/4 of an inch material. Your material is 3/4 of an inch thick. You would want to tighten this side down so that only 5/8 of an inch is between the vise and then the fixed side over there. At that point, this side's already too far. You can just loosen this side, put your piece down, and then operate off of that side only. Hopefully that makes sense. You don't have to operate both sides every single time. But that's why there's slots instead of holes. It'll allow you to articulate or move the vise like that. So I take this off. First off, you can see that this is 2 layers of MDF. The center section's thicker than the outside section. Oh, this slot right here, the slot is because this piece right here is actually an alignment fence. When you put your material in, you obviously align it with the back of the cabinet right there. That's the fixed side of the vise. But this side is where we're going to align all of our pieces. So this is nice and vertical, and this is your alignment corner. That's why we have to have 2 layers right here, because if we just clamp down to this, well, you can't do anything less than 3/4 of an inch in that case. With 2 layers, this side will take up the thickness of this piece right over here. Oh, the slot. So when you put this back into place, remember that that fence over there exists to slide your material all the way to that side. That's why I put this slot in here, so that way when you put your material in, you can use your fingers to push it up against that side right there, so you know that you're properly registered every time you go to make your cut. Here's what it looks like operating this vise from the top. So anytime you take pieces out of the vise, utilizing one side, not both, always wiggle it forward and it'll unlock it or release it. So what I want to do first is I'm going to set the right side so that we are touching. All right, so the right side is holding it in place. Let me back it off so I can get the piece out, and then I'm going to advance it just a little bit more. That was about 2 turns. This physically cannot go down in there anymore because that's too tight, and that's what I want. Now I can work off of this left-hand side only. So let me hold it in place. I'll use my other hand over here inside this slot to push it up against the fence over here. Now, I don't have one of those 3-2-1 setup blocks. I should get one, but I've always relied on this little 1-inch block. And I align the heights with the top of the spoil board, 1 inch like that, and then I can tighten down this side. And there we go. Depending on how long this piece is, you basically can operate from just using the center screws only. I'll use the centers to get it close, to get it snug, and then the rest of them to just kind of lock it into place, right? So you can see, if you look very closely, I'm not sure how much it's going to show up on camera, but as of right now, this vise is contacting quite a bit on this corner, and there's actually a super tiny gap right there. So that's touching right here because this is off on an angle due to this screw being advanced further. all you have to do is just crank it down just a little bit, and that's where the grippy material comes into play. It's going to make up that difference. And now, I mean, with 3 knobs down here, it's super easy to tighten it down with just a little bit of pressure, and that's held in there really, really well. This is not going anywhere. Very easy to operate this. And again, if you're batching out a bunch of parts, don't fool with the second screw. Simply back these off more than what's necessary, and then wiggle the piece forward to pull the jaw forward, and then your pieces can come in and out very easily. CNC machines are controlled in various different ways. My CNC machine is controlled via Mach 4 with a direct connection to the CNC machine itself. I don't have to transfer files. This one doesn't directly connect, well, it probably can, but in this case, it's not directly connected to a laptop. The files are sent over via a USB flash drive, and then you use this touch screen as a keyboard, mouse, computer setup to navigate and move stuff around, to select your files, to manually jog, manual data input. I will say that when I first saw OneFinity come onto the scene, they had this touch screen, and I thought, that's really clever. I like that. That's pretty darn cool. In reality, actually using this, I hate it. I cannot stand the touchscreen functionality. I cannot stand this little screen with a touchscreen. Bad eyes, you know, goofy fingers, sloppy fingers. I don't like operating this via a touchscreen. Now, you can obviously plug in a mouse and a keyboard and run the signal to a monitor of any kind, whatever. In this case, it is touchscreen right here, and then an Xbox controller. So when we were initially moving stuff around and working with this cart, we had the controller in one of these little cubby areas on this side over here. And then you accidentally knock it down, and then it falls and bumps on the floor and jogs the machine accidentally just a little bit. Okay, that was kind of crazy. Or then it's on the floor and you don't realize it's on the floor, and then I kicked it once. That's not fun. Or you're like, where did I put the controller? Because you put it in a different spot. Anyway, if you can get something that's more consistent, it's just going to be one less thing to worry about. So the consistency that I'm adding to this is putting the controller inside the tray, inside this drawer. And what I've found is I have to sit down anyway to use this, because this touchscreen, standing up with this thing down here and trying to, no, it's really annoying. Just get a little rolling stool, and then you can operate it at a more easy eye level. So what I found is I put the controller in this tray for just a little bit, and I thought, wow, that's actually really convenient. You're just using it basically like a keyboard, where you can jog the machine without ever having to pick up the controller, which means consistency. It is always in the same spot every time. You always know exactly where it's at without having to go look for it, and it's always out of the way, not going to get accidentally bumped and moved all over the place. So for that reason, I thought, wow, that's a pretty neat idea to put the controller inside here and next to your bits. You always have to, not always, but you know, most often manually jog the machine to the front when you're changing bits anyway, so it kind of makes sense to put it here. So with that being said, let me bring you in closer and I'll show you what we have here, which is bit tray number 1, which will be in the machine file, and then I'll install bit tray number 2, which I think is a better fit for what I want to accomplish right here, which is again in the machine file. Bit tray design number 1. So on this side, you can clearly see just a ridiculous amount of holes, way more holes than what you would need for 1/4 inch shank bits. Now, I sized the drawer height, this tray height, based upon the vast majority of all of my 1/4 inch shank bits. If it's a 1/4 inch shank with a 1/4 inch cutting diameter or less, I think 2 3/4 inch is the cutoff. Nothing's really going to be longer than 2 3/4 inch. If it is longer than 2 3/4 inch, this bit right here, that's where these slots come into play. It's cut with a 1/4 inch ball nose, 1/2 inch ball nose at a 1/4 inch depth. And what that allows is the entire bit is below the surface, so nothing can slide across here and scratch up the cutting edges. Also, it should not interfere with this controller wire any. Yes, this controller wire is kind of in the way, which we somewhat addressed that in version number 2. And also, because this is, you know, 1/2 inch wide, you can get your finger in here to get the side of the bit to pull them out. So there's that. There's a pocket right here for the controller. This pocket ended up being just a little bit too big. Not the end of the world. And then there's a big pocket over here for some various other stuff, other things like the wrench, calipers, and some other stuff. A generic pocket like that works, but I don't like it. I don't like it because I don't want this precision tool to be rattling around and stuff whacking into it. And I just don't want stuff to just rattle around for whatever reason. Also, Bits and Bits provided some bits for Mr. Bill, so he gets a sticker as well. So there's that. Let me take all of this out and put version 2 in, because version 2 is much better than this one. And what I would imagine the majority of people will actually cut. This is bit tray number 2. So right off the bat, this lower left corner is actually a complete cutout. There's no pocket here. It's just a complete cutout. And that is for the remote control. It fits, or the controller. It fits in there much better. And this wire can now be pushed off to the side. If you wanted to, you could put a couple steel pins in these 1/4-inch holes. Or what I do is all of my router bits, I keep the broken ones, because that 1/4-inch shank is sometimes handy for referencing purposes. You could use this row over here, this column over here, for your broken router bits, and it'll keep the wire over there. Now, once the wire is over there, as this is operated, the wire is always out of the way, and this is in a much more fixed location. It's not going to rattle out of the way. So I think the controller here is an awesome move. This slot right here is just a long slot for the collet wrench. This is not his collet wrench. This is just a Harbor Freight wrench that I have that fits the collet. So it'll fit in here. Mine's got an angle right here, so it doesn't fit in, but that's why this is here. We'll slide this off like that. That's for the wrench. This cutout right here is a nice, precise cutout that I came up with a few years ago on my Panto router cart for the dial indicator, or the calipers rather, the calipers. If you're not using a set of calipers for going to 3 digits with imperial numbers, so 0.250 for 1/4 of an inch, or for millimeters or whatever, I encourage you to start using it. This is one of the most handy tools for use around the CNC machine. Well, and the Panto router for that matter. But that's where I got this already pre-made vector I've already got, so I didn't have to measure. That was really cool. It's a nice little pocket for that to sit in. This doesn't really wiggle around. It's always in the same spot, and you have a relief cut right here to pull this out. So that's pretty cool. This is just generic storage for whatever. That doesn't fit, so we'll throw that over here. Of course, store whatever you want, wherever you want, but you have much more storage with all of that. Now, you have 2 different bit locations on this one, and what you will obviously know is you only use a couple bits over and over again. You don't need a tremendous amount of holes. So the most commonly used bits can live their life up here in the front, and the stuff that you don't use a lot, like something like this Spoilboard flattening bit, astro-coated from Bits and Bits, by the way. This Spoilboard flattening bit can just live its life in the back, out of the way, no big deal. Again, you got some long bits that can't reach, or they can't fit in here because they're too high. You can set them in these. These are the exact same slots as I had in the last one, except they're a lot longer. Now, I didn't really worry about putting stops in here to stop one bit from whacking into the next one if you have a bunch, because the only motion this drawer is going to see is front to back. It's never going to want to do that unless you know, park in your garage, and this is in your garage, and you hit it with your truck or something silly. But then you have more problems than just bits breaking. So there you go. Most commonly used stuff up front, extra storage right here, extra storage right here. This controller is nice and tucked away as it should be. It's a dedicated spot for your collet wrench, some extra space for whatever. Oh, high contrast rulers. I'm getting old. These are amazing. Here we are in the SketchUp design file, and if I unhide everything and zoom out, you'll see that we were looking at design number 1, but there's a lot of stuff in here, way more than what's necessary, but I don't like to delete stuff. I just like to leave it there for future reference for whatever reason. So we have design number 1, the layout for design number 1, design number 2, the layout for design number 2, the CNC layout for design number 2, and then these are actually just pages for my reference. These rectangles are sized to the same ratio as a sheet of paper, and this just gives me a good visual representation of where I want to lay out on the plans. when I actually make the plans and put dimensions on everything. So disregard these rectangles. They're on their own layer or their own tag called plan pages. You can turn those off if you want. These CNC files, they are on S1, S2, S3, S4, S5 tag. Those are just sheet numbers, just handy reference for me. And of course, let's get back to design number 1. So I'm going to click on the D1 overview scene. I've got a bunch of scenes you can walk through if you want. But this is design number 1. Not a lot, not crazy different than what I ended up going with, but it's kind of like a completely different construction. So this is just basic frameless cabinet construction utilizing a torsion box base for stability. I initially had the torsion box up on top. I wanted to put a torsion box because the benefits of a torsion box is great flatness and stability without a lot of mass. But it interfered with some T-nuts, so I moved it to the bottom and then realized, hey, it's actually better on the bottom anyway because everything's referenced off of it, so you get the same benefit of the flatness. But if it's on the bottom, then you have a much lower center of gravity. So I like that. I like that a lot. I did go with the tripod design from the very beginning, so 3 casters from the very beginning. I knew that was something I wanted to incorporate. I knew I wanted to do some feet of some kind on the corners to, an insurance policy to stop it from tilting. In this iteration or this design, they're on the exterior of the cart, kind of in the way, sticking out a little bit. I didn't like the execution of this, and again, the angle's wrong. The angle needs to be the other direction so that when you're in the front, this acts kind of like a recess, like a toe kick. This could probably be trimmed up quite a bit to that surface, but I figured just add a little bit of a shelf there for dust purposes, probably a waste of material. The vertical table was in the back right, I'm sorry, the right side of this side rather than the left side of this side, because I don't know why I started over there, to be honest with you. But it is a bunch of T-nuts, and that's just way overkill for something as simple as a vertical table. Just make a vise jaw, as I did in the final design. What else? This is storage. I think I said that. These drawers are, in fact, drawers. They're not all the way through, so they just come out a little bit, just a regular drawer. And that's because this design, I had an air compressor back here. So our thinking was, well, you drill a hole right there, drill a hole right there, and you feed the air hose all the way through, and now you have air hose in the front, compressed air in the front. And you probably just put a hook right there and hang it on the inside face right there. You have air compressed air. Whew, getting tongue-tied to blow stuff off. And then also this other cavity right here was for a shop vac. Put the shop vac in the back so you can just, do your hose management or whatever for the dust collection on the router. And the thinking was to put these interior dividers in place to kind of block the direct line of sight. You're still going to hear these, obviously. It's not soundproofing, but it should, muffle the sound a little bit, bring the sound down just a little bit. Everything else is pretty much the way I initially had it. The way I have it in design number 2. One other reason why I did not want the vertical table right there is because if you want to, for whatever reason, take all of this stuff off and then use the maximum capacity of the Spoilboard, I wanted the entire material to be supported with the Spoilboard on the corners anyway. I wanted the corners to be solid, so I don't like that we're getting rid of the corner of the Spoilboard there. Didn't quite like that. Again, if you want to build this, though, all of the information's right there laid out for you, so you can cut it and build it without a CNC machine using table saw and circular saw only, all that good stuff. Let's jump over to design number 2, and we'll talk about the slight changes, mainly wire management and hole placement. So on the prototype in my shop, I have the holes on the top surface, and Bill preferred them on the top, so that's where we put them. And I don't personally. I want to see them in the front because when this dust boot and spindle come all the way to this corner, the touch screen, which I also don't really like in this application, the wires for it are kind of in the way. They're not actually in the way, but they can be in the way. So putting them down here will just solve that, but Bill prefers the clean look of the front and put the wires on the top. So you have the option. Do whichever one you want. Another hole that is different is this hole right here is included in the vectors. I drilled this by hand because there's a wire that comes out here and then feeds into the x-axis up here. That's included in the vectors. This hole is included in the vectors as well. This is the wire hole for the wired controller, and it dawned on me that most of you probably don't have a wired controller. Bill actually has a wireless controller that was giving me some fits, and I was giving him some fits, so I said, forget about it. I'll just give you one of my Xbox controllers and be done with it. So we put a wired Xbox controller in here, and I prefer the wired controller. I've gotten to where I just prefer wired connections anyway with computers, because with CNCs anyway, because I've had several situations where I'm using a wireless keyboard and I'll press a button, it sends that signal, but it doesn't send the fact that I let go, and it keeps going in that direction. So I don't really trust wireless personally anymore. So that hole's right there for getting the wire, getting the wired controller in the tray. What else? Some other holes that are in the file that I didn't deal with are every hole on this panel. So the holes for the feet are in place like they should be in the vectors, and the holes for the threaded rod and T-nuts to go through the side panel are in here. One thing that I did include is matching holes right here. So if I turn on this tag or this layer threaded rod, I just extended some cylinders to give myself a visual representation of where these threaded rods will actually interact with on this other panel. And I added these 4 holes right here. They're not necessary, but if you're building this, or when you go to build this, I would suggest putting some T-nuts in here just in case. Maybe on the inside face, I don't know, just in case. Because you never know. Maybe down the road you'll come up with some idea where you can connect these 2 hole locations and have something else, something extra right here. You never know. So adding those 4 holes, it doesn't hurt anything, and it adds some future proofing. Now down here, these 2 pieces of threaded rod, I saw no need to add the holes into this face over here. So if I turn off the threaded rod tag, you'll see that there's no holes there. I think that's the only major changes from when I built it. Oh, I also added, let's start hiding some stuff. Actually, let's just double click to edit this part, press Y to only select it. I also added some more tabs on the top here to locate this panel inside the frames. And that'll make sense when you start assembling. That's basically the design. So let's, the layout. So one thing that I always do, let's go to the layout right here, or just press U to unhide it. What I always do is once my design is done, or like 95% done, where the majority of it's done and I'm wanting to start figuring out how much material I need, I copy everything. M for move, control brings up copy, and then I disassemble the copy into a layout like this. And what that does, if I just go to the layout tab so we can see it all, it allows me to nest things the way I want to nest them. I have not found a nesting software that I really, really like, or a nesting plugin, or a nesting extension. Even the VCarve nesting. I imported all this stuff into VCarve and nested it no matter what settings I chose, no matter what angle to twist it, everything that I tried. VCarve was saying this takes 6 sheets. And I'm proving to you right here that it takes 5. So that's one of the reasons why I don't really rely on those nesting software, unless it's just a bunch of really goofy, complicated, weird parts. Yeah, then we'll do some nesting, some auto nesting. Otherwise, I'm just going to make it myself. Now, what I did here is I, for the first time, actually moved everything 1/4 of an inch away, and that was a mistake. I thought that would be good because I'm using a 1/4 inch bit, and hey, you just make it the width of the bit, and then put a tab in between both of these pieces when they're being cut on the CNC, and the tab kind of locks everything together. Well, using 0.250 for the spacing here was wrong, because when I imported this into VCarve, that 1/4 inch wasn't enough in some situations. I don't know why. It just wouldn't work, and it would not make a tool path in between some of them, and it would in others, and it was just being weird. So if you do this where you're moving stuff around, if you're using a 1/4 inch bit, use 0.26 or something like that. Just make it a little bit bigger. The drawer bottoms. So these green rectangles are the drawer bottoms, and they are we're basically utilizing the waste of these frames. Now, when I designed this particular setup here, I went back and forth on the interior space of these because I eventually figured out that, hey, this is the almost perfect size for the drawer bottoms, right? So then I tweaked it to where that it would actually work. Two of these make up one of the drawer bottoms. If I go to this scene up here, you can see the drawer and a line in between because that's two different components, two different drawer bottoms. Doesn't matter if you make this bottom out of one piece or two pieces, it doesn't matter. It's going to function the same. Put a biscuit in between to keep these aligned, it doesn't matter. Don't put a biscuit, it doesn't matter. That's the idea for the drawer bottoms. Now in the video, I'm not exactly sure if I'm going to show it or not, or how I'm going to edit it, but I goofed up and I designed all this with a 1/4 inch bit in mind, but at the last minute I decided, just use a 3/8 of an inch bit, you can cut faster with it. So I changed my toolpath for 3/8, forgot about this, and then my waste material was too small. So I ended up having to use my extra sheet for the drawer bottoms, making them a full length piece. So there's that. Also, most of this is just rectangles. You can take this piece, all of these basic rectangles, and get rid of them. You get rid of them on the CNC machine, and then just compact this down to where you don't have to cut as much on the machine, and then just use a table saw to make these rectangles. Table saw, miter saw, circular saw. That's really all you need for all these basic shapes. Or if you got the capacity, just run them all the way through. Or if you're going to be tiling everything anyway, just leave them on there. So that's the layout. Once I have the layout done, one thing too, I always lay out on a sheet of plywood, 48 by 96 inches. This is MDF, which gives me another inch. I have another layer over here. MDF is 49 by 97, but I purposefully like to use just a sheet of plywood dimension, 48 by 96, as my rectangles, because on my machine I have to use a screw on each corner to hold the sheet down, and I know if I have a 1/2 inch all the way around, I'm safe for the most part. For example, this piece right here, I ended up not cutting on the CNC machine because of the corners. But that being said, I've shifted some stuff around a little bit to gain better access to the corners, and that's specific to my workflow cutting stuff out. So you can see that. Then, once I'm satisfied with all of this, I moved it over to here and exploded everything so that I could delete the thickness. This is just 2 dimensions. There's no thickness here. And what that allows me to do is group these, what were exploded geometry, into a single component, and that's where I have S1, S2, S3, and all that, and that's what I import into VCarve for the actual toolpath creation. I think I mentioned this, that's what I use for my dimensions. Don't even worry about that extra stuff over there. So now let's talk about the assembly. We can jump into assembly. The drawer construction is obviously very basic. All I used was glue and brad nails. That's it. Feel free to add screws. I don't think it's necessary in this application. I've built several utilitarian boxes, drawers, and trays like this with just glue and brad nails and MDF, and they all work just fine. I did not want to add screws because MDF has a tendency to split when you screw into the side of the MDF, so I did not add screws. Once the drawers are done, just set them aside and we can start on the drawer runners. These are Mortise and Tenon into the side pieces, and on this application, this particular area, I used glue and brad nails only. Again, no screws. You'll find that I didn't use hardly any screws on this until I got to the top, adding the top to the frames and the casters. The CNC and then the casters, that they kind of really lock the envelope of the structure together, and then everything on the inside is basically held in place with, again, a bunch of brad nails, but there's mechanical connections here, so everything kind of clicks together, and the brad nails just kind of hold it together. So you don't have to use glue and screws on everything, is what I'm getting at. Now the interior box sides can be added to the frame, and I probably said it already, I added the tops to these interior boxes way too early. They should be the very last pieces to be added. Don't add them right now like I did. When doing the overall general assembly of this, where you were adding the interior box pieces to the frames, go easy with the nails. Don't worry about screws and all this stuff. Just go easy with the fasteners, because you don't want to accidentally lock these pieces in out of square. So once you get to the point where the top is being installed, the top actually fits down on top of the frame pieces with 2 tabs per frame piece and a pocket, 2 matching pockets on the bottom side of the top panel. And once everything kind of clicks down into place, the top will square the base. At that point, you can just go crazy with brad nails and just put a bunch of fasteners in there, do whatever you want, because the top is what will square the entire structure. For the most part on the top. Wait until the caster blocks are installed to really go crazy with securing the bottom side of everything. Now for the top supports, these just slide into place. There's no right or wrong time when to put them in. They're just friction fit to sit in place. The only purpose of these pieces is to prevent the top from sagging against gravity. There's nothing to be gained by fastening these or securing these into place. There's nothing to be gained by securing them, so don't secure them. Just slide them in place. If you ever have to remove them for whatever reason, for better access, for something, you can pull them back out. Now we very, very, very carefully flip this thing over to install the casters, and for the back 2 solid casters, I drill holes in the MDF piece first and then attached the casters to it, and then glued, nailed, and screwed that MDF piece to the bottom side of the cart. That locks everything together. Now, one of the reasons why I said don't go crazy with a bunch of screws or anything, or nails, or don't waste your time with glue on the interior of this structure, the main box pieces, is because when the CNC is in place on top, that's going to really lock the frames together. And this long piece connecting all 3 frames together for the casters, that is glued, nailed, and screwed into place. So that really locks the structure together as well. Next up, we flip it over very, very, very carefully. Hopefully you have someone to help you do that. But flip it over and we can install the insurance policy feet. I installed them once again backwards when I first did it. Install them so that the angles in to the center, top down to the center of the cart. That way, on the front side of the cart, it kind of gives you a little bit of a, like a toe kick room. Finally, the CNC machine can be added to the actual top of the cart. Now, you'll have to go through the squaring process to make sure everything is nice and square, but you should also be able to pretty much follow the perimeter of the top panel. It is cut precisely square, so we'll just leave it at that. I secured this machine by adding 1 bolt into the interior corner of each one of the feet. Just a through bolt, secured it with a washer, a lock washer, and a hex nut. And then once 1 bolt was in each corner, I used screws into the remaining 3 holes. Now, just like adding the caster block down below, the long caster block down below to lock the frames together, when you put screws in the perimeter of the CNC mounts, that's going to lock the CNC to the tabletop to the frames down below. So that really locks the envelope of the structure, and then everything else, like I said, and the inside is kind of really located and held into place by geometry, and then kind of tacked into place after that with brad nails. So you don't have to go crazy with a bunch of screws on the interior. This is where the machine file starts, and it starts by locating the spoil board. So you can see these little corners that I have sitting on the top of this cart. Install a V-bit and scratch the corners that are located in the machine file. Now these corners aren't the 100% exact capacity of the machine. If you jog the machine positive X, positive Y to the maximum, it's something like 32 1/4 inch by 48 1/4 inch, something like that. I just wanted to keep it as simple as possible, get it to a whole number, and put it as 32 and 48 and be done with it. So that's the location of these little corners, scratch those into the tabletop or the cart's top with a V-bit, and the only purpose of those is to locate the spoil board when we install it. After cutting the locating corners, we can use a longer reach end mill. I believe this is 3 inches in total length. A standard end mill that has like a 1-inch length of cut isn't long enough to get down through the tabletop here, so I had to use a longer bit and kind of extend it a little bit out of the collet, more so than what I normally would, but everything worked out just fine. Now we can cut all of the holes for the T-nuts. And for the T-nuts to be installed, it would be handy if you could just whack them with a hammer, but whacking them upside down with a hammer is not the easiest thing. So I had Bill on the bottom side pushing the T-nuts in place, and then I used this setup on top, a bolt with a fender washer, some nuts to take up some space, and another fender washer to put through the holes and pull the T-nuts up into the top of the cart top. And it took about 10-15 minutes. It's just boring and repetition. It's not the end of the world. Just get it done once and be happy that you don't have to do that again. The cool thing about putting the T-nuts in the top of the cart versus the bottom side of the spoil board is you don't have to worry about them clogging up if there's no hole that's all the way through it, through the tabletop. And you also don't have to worry about replacing them every time you change the spoil board out. That's quite annoying. So in this case, if you have to replace them, you just pop one out and replace it for, damaged threads or whatnot. Now the spoil board can be added. So I just zigzagged a little bit of glue in between each one of the holes, set the spoil board in place, put a heavy sandbag right in the middle for some weight, and then on each one of the corners, I used a drywall screw and a washer from below the holes that we just cut to screw through the spoil board and lock it in place and hold it down. I let that sit overnight so the glue could fully cure, and then the next day we came back and I drilled the same holes, or used that same program to cut all of the T-nut holes, as well as some indexing pin holes into the spoil board. Once that is done, I cried a little bit on the inside because I had to flatten the spoil board with the surfacing bit, which this thing doesn't have dust collection. MDF dust is brutal, and I started out holding my dust collector hose close to it to kind of catch it as it's being cut, but man, that was brutal. I just turned the exhaust fan on in the shop, walked away, and pouted at the mess that it was about to create, because I knew it was gonna be horrible. Once the spoil board is surfaced, we can work on the fence. Now for the fence, I'm just going to show this to you in SketchUp because the way I did it was unnecessarily overly complicated. So basically these rectangle pieces for the fence, use some double stick tape or something to hold them down in place on the far left side of the spoil board, because the holes line up perfectly for that, as well as the one that goes along the back. So put this down, select only this geometry from the machine file to cut the T-nut holes as well as the indexing pin locations, and then cut 2 pieces. Cut one, take it off, put another one on, cut that one, because these two, like I said, are identical and they just click down into place. Then on the machine file, you can trim these faces up so that you have a perfect corner to work from. Again, well, actually, I think I did actually record this. Yeah, the next step is to make some of these adjustable stop blocks. And we have a working machine file. We can actually use the machine file to cut these slots out. And this is the first point where you realize how this machine file works and how super handy it is to be able to locate stuff in a corner every single time and work off of the machine file for everything that you create. It is super handy. The final step on the spoil board work is to flush trim the spoil board with the top cutout down below for the vertical table. And you will have to chisel at the interior corner of the vertical table area so that pieces reference off of that exact corner. Next, we can add the vertical table left fence. Now this particular piece is only there to make sure the material you put into the vertical table remains perfectly perpendicular to the spoil board surface. So parallel with the z-axis. That's the only point of this. It's going to be further held in place every single time you clamp something down inside this. So don't go crazy with glue and screws. Just set it in place, use a bunch of brad nails, all you have to do is lock its position. Now you can build the movable vise part of the vertical table. Just add the two pieces together, referencing off of that center slot where your fingers go to push the material up against the left fence, and put some cork or some cork rubber on the inside for extra grip. Throw the threaded rod into the holes and put the nuts in place, and you're ready to go, ready to use it. Oh, before you add the knobs, I will recommend adding a flat washer, regular washer, flat washer in between the knob and the movable side of the vise, and that is just to allow a little bit of spacing between the knob and the vise jaw, because if you don't do that and the vise is racked just slightly left and right, then the wings, I guess you could say, the outermost point of the knobs will rub on the front face of the vise. You don't want that. Add those washers, stack it out just a little bit, and you won't have any problems with interfering with the knobs moving when the vise is racked. Finally, the very last step is to add these top pieces to the interior boxes. Again, I added these super early in the build and had to remove them not once, but twice actually, because they were in the way. So these are the very last things to add. Install them with screws, of course pre-drill so you don't split the frames, but add them with screws so you can easily remove them if you have to work on or replace some of the T-nuts that are located above them. This is the machine file template. Now it's a template, so you can't accidentally overwrite this by making some changes and saving it. You'll have to save it as a new template. But anytime you open up a template, you'll have a job setup screen that you have to confirm before you start. So let's just press OK, and it's going to say you have got some errors with all these toolpaths. Don't even worry about that, because every one of these toolpaths is independent of one another. So right off the bat, you'll notice that my toolpaths are on the left-hand side. By default, they're on the right. I don't think it makes any sense whatsoever to have them on the right. As well as the Windows toolbar, I put it up at the top because all of your menus are top left. Why not have all of your mouse stuff top left? It just makes sense. It just makes sense for me. So that's why my toolpaths are over here. Now I want you to notice the Layers tab and the Toolpaths area. For all of these layers, as we go through building this, there's correlating toolpaths already made for this. So let's just say you open this up to do a basic job. You're going to do your normal V-carve sign. You don't need all of this. So once you open up the template, the first thing I want you to do is right-click, delete all. Delete all of these toolpaths if you don't need them, opening up the template file. I think this kind of slows stuff down the more crap you have in here. So anyway, I'm going to show you how we built how I built this machine file. First thing, let me turn off all of the layers and turn on the Spoilboard corner locations and the toolpath that goes with it. So this is just a very basic corner. It's 2-inch lines to form corners all the way around it, and this is what we used to establish the location of the Spoilboard. Very, very basic. Let's turn that toolpath off, turn that off, turn on the next one, which was T-nut centers. So when I designed all this, I was getting kind of confused between the 1/4-inch pinholes and then the T-nuts. So this was a cross. Every one of these was a cross, and I deleted the top leg of the cross to turn it into a T. Very simple, but that intersection gives me the center point for the T-nuts, and that still allows me to use an X for the 1/4-inch pins, which I'll show you in just a second. Actually, we'll go ahead and turn those on. So there's some 1/4-inch pins on a different layer as well. They're red as well, and they're X's instead of crosses, right? So what I used these T-nut centers for is the T-nut shank holes. All of these holes are for the T-nuts. That's, if I'm not mistaken, a 3/8 of an inch diameter hole is perfect for a 5/16/18 T-nut. I believe that's the case. But that's all of the geometry needed, again, minus this area over here for the vertical table. There's no sense in putting T-nuts there, obviously. So that's all of the geometry, and we have the tool path for the T-nut shank holes and the 1/4-inch pinholes. One quick note about the way I name my tool paths. I name my toolpaths primarily, there's a couple times where I didn't do it, like this drill, but primarily I put EM250 for an end mill that's 1/4 of an inch in diameter. Sometimes I'll put BN500, that's a ball nose 1/2 of an inch bit. That's how I name them, just so I know right off the bat what bit is used for these. So there's that. There's the toolpath and the drill toolpath for all of the Spoilboard geometry ready to go. Let's turn those toolpaths off and collapse that. Then we have a single Spoilboard flatten toolpath, and this is just set up ready to go for the bit that I used. You can use this if you want, but there's an offset on here, so it extends to complete the entire toolpath, the entire Spoilboard, rather than just going inside of a circle, or inside of a vector. So there's that, and now we have the Spoilboard corner fence toolpaths. So the corner fence cleanup is right here. So the initial rectangles are 3 inches in width, and they reference off of the perimeter of the Spoilboard. So once you secure these rectangles, they're going to be out to right there. That's how big they are. Then we're going to use these toolpaths to clean them up. I'm getting ahead of myself here. Actually, we have to create these first, right? So the first thing we do is put the rectangle on there. Then we use these 2 toolpaths to actually cut the holes in this rectangle. You do that twice. One for right here, and then one for up here. And then you stick them in place, and then we use these blue line vectors to clean them up, establishing this interior corner. So what that'll allow you to do is have a corner to reference off of every time you want to put a rectangle down here to do your actual jobs. Now, there's also an extra line right here, V60 mortise reference. That means I used a 60-degree V-bit and made this particular line right here for mortising. And I'll show you why that's handy in just a little bit, but just keep that in mind. Also, this particular vector right here, this blue vector, I did end up copying it to a layer called calibrated locations. So once we have this corner established, that is a calibrated location. Once we have this straight line established, that is a calibrated location. And then once we figure out the vertical table, that's a calibrated location as well. So let me turn off all of this extra stuff that we don't need, and I will turn on calibrated location. So now we have a corner up here. This is the corner that the fence is pointing to or is creating. So if I open up this and I have a 12-inch by 12-inch rectangle of piece of plywood that I want to put on the machine and cut something out of it, what I would do is first go to my drawing, rectangle, reference off of the top left, and I'll type in 12-inch, I think that's what I said, 12-inch by 12-inch, and I'll just click this corner, and boom, there's my rectangle. There's where my job is. That's where I design all of my cuts. That's where this machine file really comes in handy. You don't have to locate anything. You don't have to use the corner offset or the corner origin touch plate. You simply reference off of this established corner that this machine file created when we ran this, the stop block cleanup. So that's one of the main reasons why this machine file is super handy. There's no more measuring offsets and all that good stuff for the pieces that are located on the machine. After the corner fence, let's go back to our layers. What else do we have? Large adjustable stop blocks. I'm gonna go ahead and delete this. Oh, also, by the way, all of these layers, you can click the little light bulb to see it. You can also see that there's a lock icon on some of these. You can right click and say lock or unlock. When they are locked, you cannot select them. So I can't accidentally delete this. I cannot accidentally move it. There's nothing I can do to it to change it. But when it's locked, you can still reference off of it. So if you wanted to draw a line from this midpoint, you still get your snaps. Like the midpoint snap, you can still snap to it. And of course, I just showed you the rectangle off of that corner. So locking layers is handy and something I do all the time. Lock the layers you don't want to mess up. Next up is the large adjustable stop blocks. These are the stop blocks that I cut and created in the video. It's just a basic rectangle, and these are slots cut for a for bolts to go through. So there's the tool path to get those done, ready to go. All you have to do is throw a piece of material on that is these dimensions. I included those as well for a quick reference. And these are honestly just arbitrary. It's just the pieces that I had. You know, you can make them any size you want. So there's the adjustable stop blocks. We'll turn off the large adjustable stop block here. And now we have hold down clamps and some other stuff that I can't read. Hold down clamps and knobs. So this is a vector that I created in my personal machine file for my machine. And of course we have all of the tool paths as well. So this will create those wooden knobs that I showed you earlier in the video. And all the tool paths are set up for a recessed counterboard hole, a counterboard hole for the T-nut. There's tabs already built into here. And there's slots right here for the actual hold down clamps themselves. Now, what I recommend doing is if you have a piece of scrap wood, 7.5 inches by 20 inches, just find some stuff that fits these dimensions and just knock out a couple of these, right? These are all the tool paths for all of this. To cut all that out and then use the table saw or a bandsaw to separate these. There's no sense in wasting a lot of material for the width of a router bit. Just chop this off, chop, 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 and then cut the rabbet on the inside. And there you go. You got all of your hold downs. Those are sitting there ready to go. And if you accidentally mess them up, well, there's a copy of the vector and a little bit of note to go, or a little note to go with it. All of that is ready to go. It is on the hold down clamps and what did I say? Hold down clamps and knobs layer, and you can turn it off and not mess with it. It's always there ready to go. That's pretty cool. Next up is bit tray number 1. Obviously, I didn't like it, so I did not make any. I guess I did. I did make the tool paths. I did include them here. So if you want bit tray number 1, here's the vectors and the tool paths ready to go. Of course, every time you open one of these up, there's things that you have to change. First, before you calibrate one of these, you have to make sure that your material setup is the way you want it. You want to make sure that your material surface or machine bed is selected based upon how you want to cut. You have to make sure the start and stop position is set up based upon how you want to navigate the spindle, and you have to make sure the thickness is set up based upon the material that you are actually cutting out of. So basically, if you're doing any one of these, change all of this first, and any change you make is going to tell you to update all of these. Don't worry about updating them. Then go into the actual tool path and make your adjustments, your calculations. One thing that I will say is that when I click calculate here, I'm not sure if the setting's going to transfer over in the tool path. The template machine file or not. But every time I press calculate, this menu does not go away. I have it set to where calculate keeps this up, and I have to manually close it every time. I prefer that because I don't want this annoying 3D view to be popped up every single time you hit calculate. That's annoying. That's something you can change in options. It's one of these settings in here. Anyway, if you open up this file from me and press calculate and this doesn't go away, that's why. All right, so that's bit tray number 1. Bit tray number 2 is in here as well. Basic tool paths for all of this once again, and I gave you the dimensions for this cutout and whatnot, so you can cut this on a separate, table saw or something like that, and then put it on the table with the cutout right here. So that's why I put dimensions on this. Let's close that. We no longer need that. Now we need to calibrate this location, and I'm going to reference off of some images for this. To calibrate this, what I do is you can put a piece of material in here and use the corner finder touch off if you want to. I don't recommend doing that because I want you to understand how to manually do this without having to deal with a tool, right? So the way you do that is you put a piece of material in here, just like so. And then you jog the machine to a specific X value, specific Y value that is easy to write down and know. So in this case, this says I'm at 5.75 for the Y value. So the center of the bit is at 5.5. And then the bit itself is a 0.25 inch diameter bit on this particular plane right here, right? So you make your cut. You manually jog the machine to make your cut. And then you're left off with some material that is like so. It's like this, whatever this is. You made this cut, and this is the material you're left with. So then you use calipers to measure the distance from here to here. How much material is left? All right, so you know the center axes of the machine right here. You add the radius, you add the thickness left, and that's the exact location of this. Does that make sense? You do the exact same thing in this direction to establish the exact location in this direction. I'll put a picture on the screen of my notes that I used to do this exact setup, and you can see the math that I did. You start with the exact location of the spindle to begin with, and then of course the radius of the bit, whatever's left over, gives you the distance away from this exact corner that you need to locate. All right, that's how you find this particular corner location. Now there's some calibration here, maybe that you have. What am I looking for? You need to make sure that this is parallel in the Y direction, right? So I made my cuts here, put another one up here, made my cuts, and I found that this location was 2/1000ths of an inch off of parallel with the Y travel, if that makes sense. 2/1000ths of an inch. That's nothing to worry about, so don't even worry about something simple like that. Once you have this corner established, first off, I copied it into the layer of calibrated locations, and then I can work off of this corner for mortise and tenon joints. So let's turn on mortise and tenon joint, and you can see a lot of stuff right off the bat. Boom, there's a lot of information here, and it's a lot of extra stuff. Tenons are cut over here, mortises are cut over here. So first off, let's talk about my vectors. These vectors are what I copied over from my file, and it gives you all of the dimensions here. This interior vector is 1/4 inch by 6 with a perfect radius. The middle one is 3/8 of an inch by 6 1/4, or 6 1/8, and 1/2 inch by 6 1/4. Now I did this by establishing these vectors and then just offsetting them by 1/8 of an inch, and I made a bunch of them. So if you know exactly what you need, you can quickly just go to it and find it. I thought that was super quick, but I found a quicker method with this particular one. So what I did here is all of these tenons are 1/4 of an inch in thickness, 3/8 of an inch thickness, 1/2 inch in thickness. And I started with a 1/4 inch by 1/2 of an inch, and that's what that vector is. And then I created another one, a 1/4 inch more, 1/4 inch more, 1/4 inch more, and so on and so on and so on. So let's just say you want to get a 3/8 by 3 inch vector, or tenon. So you find 3/8, it's this column, 3 inches is right there. You grab that and you copy it and paste it over to here. So that's how you have a quick reference if you want a quick reference. But let me show you the exact setup here. Let me grab this and go to my rectangle so I know the size. All right, so this is 2.5 inches by 0.75 inches. So you draw your rectangle. You put a piece of wood in the vertical table, and you draw your rectangle the exact same size. What I do is I draw a diagonal line from corner to corner, and that gives you a snap location to the center, which is where you want your tenon to be. Go to draw your rectangle for the tenon, and I put radius external with a radius of 0.125 inches, which is the radius of the bit, for my corners, just so that the mortise is easy to match up. And I put the center location and then size the mortise I want, and I can drop it down there. That's how I draw a new one, but you don't have to do that. What you can do is, once you've already have this rectangle established, you can just find the rectangle you want. For this one, let's just say it was 2 and some change. Let's go with a 3/8 by 1.5. I will Control C for copy, Control V for paste. And just so you can see it, I'm going to move it over here just a little bit. That's the new tenon. I'll go ahead and delete this. Now what you can do is you can grab this, hold Shift to grab that. You go into your Align Selected Objects and align to selection the first object to the last item selected. Just press Center. It'll center it, and there you go. So if you want to draw it, use the diagonal. If you want to copy and paste it, copy it, and then use your align to perfectly center it on here. Hopefully that makes sense. So this is the tenon that we want to cut. Let me back up to make sure I got the right size. That is the tenon that we want to cut. So how do we cut this? The easiest way to do that is to just offset a vector so that it completely covers the wood. And then you draw you make a pocketing toolpath to pocket that out. Very basic, right? This pocketing toolpath is in between these two vectors, and it'll create the tenon. Very, very, very simple. There's no need, if you're using an upcut spiral bit, there's no need to score the complete perimeter for a nice clean cut. I did that in my machine file. It's just a waste of time. Everything that I've done without the scoring toolpath works just fine. So there you go. That's how you cut your tenons. Now, when I'm setting up the board in my table, let's just say I'm using 3/4 of an inch thick material, and I want to cut a through tenon on 3/4 inch thick material. So I actually want to make my tenon 7/8 of an inch. I want it to be a little bit longer. So I make my tenon stock. If there's a tenon on both sides, I make it 1/4 inch long. If there's a tenon on one side, I make it 1/8 of an inch long. Now I'll set this board into the table so that it is 1 inch above the spoil board. Then here in my material setup, I set the Z0 to the material surface, and the machine bed. I set it to the machine bed, and I set the material thickness to 1 inch no matter what. So let me go ahead and do that really quick. Let's not recalculate everything. So if you look at this image right here, you can see that I'm going to Z0 off of the machine bed, and I set the material in the vise so that it is sticking up by 1 inch. And then at that point, how long do I want to cut the tenon? 7/8 of an inch. I'll cut the tenon at 0.875, 7/8 of an inch. So that's what I did to cut this particular tenon. And here's the example that you see of it actually cut on the machine. The fit that I achieved here is slightly loose. And I want to bring that up because if you do a climb cut, a 1/4 inch bit will deflect away from a vector. If you do a conventional cut, that 1/4 inch bit will deflect towards the vector. So if you make a climb cut, it's going to be as tight as possible, the tenon in the mortise. This was a conventional cut and it was a little bit sloppy. However, this itty bitty little bit sloppy is absolutely perfect for PVA glue. PVA glue is water-based. It's going to swell the joint, and in my opinion, this is really good. If the joint is super tight, but you can still close it, then use a glue like epoxy or hide glue, because that will lubricate the joint as it is closed. So that's the fit that I achieved on this mortise and tenon. But how do you cut the mortise? Well, you take that same exact vector, and what I'll do is I'll just go ahead and copy it over here. I'll Control C for copy, Control V for paste, and I will move it, grab this, move it over to this line that I have set up on the fence. Now I take the center of this and I drop it right there. Now, I'll go ahead and delete the original. But that is my new vector for the mortise. If I turn on my layers for the corner fence cleanup, you'll see that this is the line of the fence, right? So if the material is 2 inches in width, I'll simply press M for move. Grab this, M for move. Why is my move command not coming up? Oh, because I was in the wrong tab, I guess. Grab this, press M, and now the move box is up. So if my material is 2 inches in width right here, Just move it a relative X position of 1, press apply. There you go. Now it's perfectly centered. And why I have this line here is because you can take your stock, strike a line across your material, and say that is the center of my mortise. Then you slide that material up against the fence so it lines up with the line on the fence, and then you have a perfect placement every single time, and you can just continuously repeat the same tool path for as many mortises as you want with this setup. Let's just say you're making a blanket ladder that has 4 mortises on each side of the blanket ladder. All you have to do is remove this top piece, and you have pass-through, and you still have your alignment for the center of the mortise. You can batch out all of your mortises super, super quick with this little alignment line. If you have any questions about this, or would like me to elaborate any further, if it's something's not clicking with you, just let me know. I will have no problem explaining this in any other way. But that's how you do your mortise and tenon cuts, and it's super cool, super easy, and super rewarding to be able to do quality joinery with a CNC machine. I absolutely love it. Let's turn the mortise and tenon joinery layer off. And as you notice, it's not locked because I like to copy and paste a lot in this layer. Let's turn that off. And now we have box joints. So for box joints, it's pretty self-explanatory. You have a 1/4-inch bit that's going to run across this path going down, or going the whole length of it, and then go down, whole length of it, go down for your total depth. Now, there's 2 tool paths for this rather than having to offset your material. So what I did is I basically duplicated it on a different length, different offset rather. I made one with 1/4-inch spacing, and then I copied and pasted the next one 1/4-inch away. And this tool path is set up for 1/4-inch box joints. You can create your own for 3/8 or whatever. It's very simple to do. So I have this vector set up to go the whole travel, the whole length. If you're, the example I cut here in the shop was only half the width or half the capacity of the vertical table. And I just let this vector run out the whole way. It's not that much time. Of course, you can cut it down and recalculate the vector if you want. But in this setup, I'm leaving Bill with a vector that can basically do box joints on anything that he puts in it that's 3/4 of an inch thick. So all of your drawer sides, if you want to do drawers, you want to do small boxes, you can use these 2 vectors and these tool paths to cut as many box joints as you want without recalibrating anything else. All you have to do is change your depth of cut. Now again, just like when cutting the tenons, I have it set up so that you reference off of the machine bed for your Z0. You set the material 1 inch above the spoil board, and at that point your depth on your tool path is the size of your fingers for the box joint. Again, hopefully that makes sense. And of course, you can scale this for 1/2 inch or 3/8 of an inch. You understand how this works, hopefully, and you can create any type of box joint vector you want. Also, something that you can do is, let's just say that this is oversized, but let's just say that this is your board that's in there. You can create a bunch of random circles that are 100% inside this, right? Random circles, and cut integral dowels on the end of your boards. And if you want these to be through dowels, you copy this geometry over wherever on your material here, and you cut those exact holes out, and then you have some pretty weird, unique, custom integral dowel mortise and tenon joints. So it's not just limited to box joints, not just limited to mortise and tenon joints. All of that is capable, or you are capable of doing all that with this machine file. I apologize for my tongue-tied ramblingness in this video. I'm just trying to get this information across, and there's a lot of it. So that's all that is in the machine file. Remember, before you export any of these, you should always verify your material set up the way you want to do it, and then recalculate all of these tool paths that you're going to use. Don't ever just accept this and send this out to your machine. You have to adjust for your material setup for every one of these tool paths. All right, as I'm editing this, finishing up this really ridiculously long video, there is some things that I've just kind of glossed over. The fit on these mortise and tenon joints, I mentioned this was a little bit loose but acceptable, and I still think that's the case. It's a little bit loose, but it is acceptable. If you add PVA glue to this, it's going to swell up and be even more tight. A couple things that will affect the fit of your joint. First off, you can mess around with some test pieces and implement an offset in the tool path to make it tighter or loose depending on what you want to achieve. But also take into consideration that a climb cut versus conventional cut plays a role in how tight these joints are, because a conventional cut is going to deflect in towards the vector. A climb cut is going to deflect out away from the vector. So if it's too loose, try just simply changing your test piece to a conventional cut. See if that helps. Or climb cut, rather. See if that helps if it's too loose. So that's with mortise and tenon joinery. You can dial them in very easily. Now, box joints are one of those joints that on all of my CNC cuts with box joints, they always, no matter what, tend to be just a little bit tight. And I actually never showed this completed joint from the machine. So this is the joint that the machine cut. It is super tight. It is really ridiculously tight. I had to use a mallet to seat this. And again, it's the exact same one-to-one vector or one-to-one tongue finger to gap spacing that was used for like the mortise and tenon setup. I don't know if it's just because there's so much more surface area here, and if one of these boards has just a smidgen of a cup to the board, well, that's going to affect the fit as well. There's a lot of more variables when you have a lot of surface area like this. So box joints, just make some tests, obviously, but it's almost always going to be a little bit too tight. This is ridiculously tight. I've got to really push to get this to open up. Anyway, box joints on a CNC, that's a lot of fun. The final thing that I glossed over was these 1/4-inch steel pins. This is a 1/4-inch by 1-inch steel pin. It's right there under that blue, you kind of can't see it. And these are just little steel pins. So these are 1 inch in length, and when the spoil board is cut, there are 1/4-inch pinholes drilled in for the fence. Now they're drilled in the same thickness as the spoil board, and then of course they're drilled all the way through the fence pieces. I didn't drill mine all the way through on the fence pieces, and that was wrong. So on the final thing that you saw in my shop, you couldn't see them all the way through, but on yours they should be. And the reason being is these are going to go inside the spoil board as well. Well, if these are 1 inch in length and you whittle away that spoil board down to, let's just say, 1/8 of an inch, then they're still going to be sticking through the fence pieces if you continue to reuse those fence pieces, which there's no reason why you shouldn't. So for that reason, those holes need to be through holes. That way they can eventually stick through the top of those fence pieces if you get down that far. I kind of glossed over that. This has been one of those projects where there's just so much about it. So I feel like as I'm closing this out, I feel like I left something out, which is crazy to say because how long this is. I need to shut up. If you're interested in the plans and whatnot, I have all that available on my website. If you have any questions about it, specifically about it, there is a customer service line I set up, basically a Google Voice number. That way you can text it and I can answer immediately on my phone if I get it, or when I get it rather. There's that. I don't know what else to say. You guys take care. Have a great day, and I'll talk to you in the next video.